All right, we have a lot of slides and material, so since it's full room, we're going to go ahead and get started right now. Hope everybody's pumped to be here. This is a basic talk about Internet 101, so I hope everybody's excited. We're going to relate it in broad concepts. You can convey the Internet to CISOs, like really big telephone lines. James heads up research at Risk IQ. That's essentially our hunt team and research team. They investigate exploits, and they also coordinate with law enforcement when we find major campaigns, need help doing takedowns. I work on the product side. My background is I built some of the first banking web apps that were really insecure. So I got to learn how to do forensics and eventually became a source code reviewer and pen tester. So who is here today? Before we get started, this all puts the demos. How many folks here are some sort of CISO or management level where you oversee both red and blue team activities? Okay, very cool. How many of you are red team pen testers? Very few this year. That's even better given the... We had to decide with the data whether we focused more on investigations or more on pen testing. Last year we mainly focused on pen testing. This year we made it about 70% investigations. So how many of you are blue team, incident response, forensics? Awesome. We made the right bet. How many of you are here by accident? Very cool. Last year we had a lot more people by accident. So we have like 50 slides and a whole bunch of demos to try to cram in. And I've had a lot of espresso, so pardon me if we go really fast. So what this presentation is about conceptually is it's really two sides for us of the same data coin is one way to think of it. So on one hand, we have data sets that we use to track and observe bad guys who are breaking into our customers. Using security relevant internet data sets. And what we find is most of those attacks for us fall into one of two categories. One are recon based attacks. They look for gaps in security they can use to attack, or they use impersonation based attacks. And we're going to cover both of those. The second thing that we've learned in the last year is that we can take those same data sets and TTP and turn that back around on our adversaries. So we can take the same TTP and data and start doing recon on our adversaries and start getting ahead of their next attacks after we detect an initial one. And hopefully there's some really cool stuff in there we'll be able to show you. Is that presenting well? Okay. So if you've been working in InfoSec for a while and you've been awake the last few years, the attacks we're going to show are not going to be new to you. What we hope to show you today that'll be new are the relationships between these different type of attacks and how to go deeper into the adversary's infrastructure that they launch attacks from. And this part is really exciting because this is the correlation of new data sets is what we've spent the last year doing in helping hunt down adversaries. So, and a couple of the examples, we haven't used these live examples before at a public conference because some of these adversaries are still very active. One of them we'll show you today is still out there kicking people in the teeth. I think 3 of them are actually live adversaries, and we haven't wanted to tip off the adversaries what we're actually doing to track them. So, so we will today, and hopefully none of you are in the room are the examples. So. Time check, we're 4 minutes in, we're doing good. I'm not rambling from espresso too badly. So this is the flow we're going to talk about today. We made a last minute decision. We're going to combine 6 and 7. We initially were going to have a whole separate piece on just how to do investigations, but we can't cover all the content we want and have an in-depth kind of hands-on session for that. So we're going to walk you through some live investigations as we go through the attack types. And then if you want to see more hands-on, just grab James and I, grab us in Hallway Con, come by our booth. Our booth is like all SCs this year, and we can walk through like in-depth how to correlate some of these data sets. So goals today, show you what the bad guys, what we found that are really doing that works. We believe it works because our customers are telling us it works and they keep doing it. They seem to be monetizing it well. Give red teams ideas and examples you can add to your own bag of tricks. Now I think most of the stuff we're going to show today, red teams are already doing most of these, but you might find some new twists on this. And we want to show blue teams, as most of you here, how to go from a basic attack alert beyond validating, oh, is this real? Or correlating it to a threat actor to actually going like, what all is this person up to? And what are they likely to do next? Where are they going to come at me? Are they targeting me? All these kind of questions. So last year, our presentation was about the data. So since most of you are investigators, you should know most of this data. The only data set that might be new to you is technology components. And by that, we mean stacks. And by that, I mean, any good sysadmin, has some kind of LAMP stack or some Windows stack that they prefer, some CMS, some build. We started finding adversaries can favor specific stacks as well. It's one of many pieces we can put together as fingerprints to help map them out. And so last year we talked a lot about the data. And then when we followed up with the teams that were at the presentation, we found that nobody actually put the data we laid out into practice in their red teaming. And the conclusion was it's not really about the data, it's about how to fit it into a process. So this year we're introducing a number of additional data sets, but we're going to try to put it all together in a way where you can see you can correlate it all. Some of the new things we're going to talk about that we've introduced are SSL certificates. The value of Whois for tracking adversaries and pivoting to find new attacks is degrading over time. Any sophisticated adversary is using anonymous Whois registration. So going forward, we have to find new ways to track them. And one of the most effective ways we found is using SSL facets. Another one is host pairing. We've started adding more down capture and web crawling and finding the relationships, the pulse and frequency of interlinkedness between hosts, which can tell us some interesting things. We'll show that later. Trackers is one of the most exciting ones. We started extracting out of the DOM all these different tracking IDs from, are they using New Relic for performance management? Are they using Google Analytics or Yahoo Ads? And so we'll show you how you can start combining all these new identifiers that exist in the DOM to start mapping back to adversaries. And you can actually classify them by sophistication. And then the final one we're going to talk about a little bit. We haven't released this data set publicly. We can teach you how to build it, but essentially we've also been experimenting with page hashing using machine learning. So if you have a global crawling capability, you can capture the DOM, capture all the headers, capture the technology stack, and using something like min hashing, you can create a checksum tree. And then you can use those checksums trees to start looking for fuzzy matching in properties. And we've been able to do some very accurate and effective automated detection of adversaries' new attacks that don't look the same visibly on the surface by doing underlying page hashing and header hashing and matching of components, blocks of JavaScript code, this sorts of thing. Well, it's not about the data, it's about using it together. So when we started studying, so after our presentation last year, we decided to spend some time with some pen test teams, some recon teams, and so my group and product spent a lot of time in the field working with people, seeing how they went about their day-to-day job, what were their TTP. James's team and our data science team started studying our data on adversaries. And what we came up with is, off this given data set that we see used, the use case was actually trimodal. And what I mean by trimodal is simply that the largest data sets used were typically by the blue team within an organization, but they're actually slightly different data sets used by the adversaries in doing recon and targeting the organization that we would often find blue teams didn't have and leverage. And then we found red teams additionally, again, used another subset of the data. So all these three groups are operating on different subsets of the same data, which means they're going to come to different conclusions and naturally have some gaps. So we want to unify all this data. And unified, the data would look like this. So these different data sets, a lot of times we find organizations. Can everybody hear me without the mic? Can you hear me at the back? No. Some of you can, some of you can't. Is this thing detachable? Looks like it is. Oh, it's taped down. Okay, I'll speak really loud. So of these different pieces, we found things like, we have found that brand usage, brand keyword usage, even logo usage and copy and use is great indicators of attacks being set up and weaponized. They're indicators of future attack, and we found that a lot of organizations will have this data. The marketing team and sometimes the legal team might have some domain infringement monitoring, some brand and logo reuse monitoring, but in most cases that data is not actually shared or effectively accessible to the security teams and the hunt teams themselves. And the same with some of these other pieces, like SSL certs. We found a bunch of orgs where the IT team either internally or had a service that they used to try to track all their SSL certs globally and maintain an inventory of them. They don't share that stuff with anyone. And that's great information in using to help map out your own infrastructure and understand your attack surface you have to protect. You know, and then likewise, the blue team will sometimes have this abuse box and fish list stuff that the red team doesn't have. Someone in marketing has official social media profiles and what's allowed to be used for corporate like image shots and all that, and the blue team usually doesn't have that. And that's actually really effective recon data. So we want to pull all this data together and use it essentially to reveal new associations, map out bad neighborhoods. For those of you that don't know, what we did, we were in process of doing this at DerbyCon last year, but we acquired Passive Total, and we put Passive Total, which is, it's a free community edition product for you to use in investigation. It's got a UI, or you can just do queries through the API, but we dropped it on top of our data sets, and we're slowly exposing these data sets out through Passive Total so you can have access to them in the community. So let me give you a quick example of what we can do with these correlations. And this is just purely automated that we did ourselves. You could do this through APIs, these data sets. So the first thing was we had an example of a customer being attacked, and that this particular adversary is counterfeiting their goods. So we've got some logo detection. We're looking for logo. We're looking for keywords. And we start mapping out, and we find some properties that are technology under the hood. So starting with this top Jordans, which is an impersonation site, we're capturing the DOM, all the web components, the headers. This adversary favors the Zencart platform. There's 12 different cookies. Those cookies map to some trackers the adversary uses. We have whois registration and some common keywords. We were able to break this out and go out, and we found literally thousands and thousands of associated sites over this multi-year history. So this adversary is a professional counterfeiter, and they're constantly expanding out and using new things. And so we combine passive DNS with whois with our trackers to pivot out, and I'll give you a visualization of this. So once we mapped all this out, essentially blue, so this gives you an idea of the depth of what you can find combining this ID. The bulk of what we found, when we say IP, that's passive DNS. So a lot of this historical stuff is dead. So the bulk of what we found was using passive DNS. But then using whois, we were able to find new domains spinning up pretty quickly. And then through trackers, we're able to find even additional relationships. And the best thing about trackers is it also told us where they were reusing old infrastructure, old IPs and stuff that they'd popped in a new domain name on top of, and we're starting to run some new campaigns. Whenever trackers are live, you know there's something live that's going on there that's a threat. So that's a simple way to visualize this. Time check, we're 15 minutes in. Okay. So this gives you some background context for what we're trying to do. Unify this data. Now let's talk about the attack patterns. So what we have here are two different sets of attack patterns, and we broke this up. One is by frequency, and it's purely data-based. So the first 5, and there's actually 6 here, we popped in a new one because we're seeing this grow pretty rapidly, and we thought as investigators this one will be an interesting one for you. But essentially, these are all based off data. This is data frequency. These examples are based off of pulse, in that the frequency is much lower. We collected the second set of data from running surveys and interviewing CISOs. So these are the things that caused them the biggest monetary impact or loss to their organization. They got compromised they didn't know about. So this is mainly for the red team folks who wanted to show, and this is the interesting stuff for the blue team hunting. I'm going to swap the order so we can see how much time we have for demos. And given most people are investigators in here, I'm going to roll through the weak attack surface stuff pretty quickly. Again, I don't think this will be new to most of you, especially if you're red team, you should know all these. But we've got 5 categories. The only one that has raised some eyebrows is that we added in EU privacy regulations. The reason we added them in is because in the EU, privacy regulators have turned into, as far as our customers consider now nation-state adversaries. They're deliberately targeting U.S. businesses operating in the EU for privacy violations in a way that they don't target EU businesses. So our EU customers say, oh, we just get a slap on the wrist. Our U.S. customers say, we get a six-figure fine. So we've had customers that are getting very large fines that stack up into the high 6 and 7 figures, which is a real impact and loss from a nation-state actor. So we're going to go ahead and include them in this. The first example here is what we like to call the pre-owned company. And the pattern that we've seen, which the CISOs that brought this to our attention have described, we had one CISO that became a new customer that this happened twice, 2 in a row in 1 year. The company gets breached from the inside. How does this happen? They're kind of confused. We've got an organization that has pretty sophisticated perimeter defenses. They've hardened things. They've got a good hunt team. They're really not easy to break into. And then all of a sudden, they've got actors from the inside, and they start doing investigations, and they have new ingress and egress points that they didn't know about. And what happened is the organization decided to go acquire a company. That company's often a partner. They already have some network ties and relationships in that are filtered and controlled. What we've seen, the pattern that's been exposed, is that once they do the forensic investigations, we've literally had cases where we find that within 24 hours of the S4 document, so you file an S4 document, which is a public document after your letter of intention to acquire. When the S4 document goes public, we found organizations that have been breached within 24 hours because these third-party partners and subsidiaries are usually very weakly defended. They might have one security guy. So they go breach them. They tunnel inside, and most of the breaches come through just simply weak web assets and weak web servers. And they tunnel inside, they drop their back doors, and then they go dormant. And they just wait until they start seeing new IP address ranges, new networks being advertised, and then they conclude, oh, now we're probably plugged into the corporate parent. And they use that as a backdoor to tunnel in. So that's the first one. The second one, third-party hosted marketing campaigns. This one, again, if you've red teamed at all, this is probably pretty obvious, but it grows really fast. Marketing budgets don't align with IT budgets. Marketing budgets are project-based. IT budgets are annual cyclical. So marketing comes along and goes, hey, we need 10 new servers Friday because we got to launch this new campaign for XYZ. And IT goes, we can't do that. And they're like, no problem. The people who are building our creatives have a very expensive option that we can sign up for to throw these up in rack space. There's some random hosting, and they're going to throw them up on an old version of WordPress. And, you can just set your stopwatch till they're breached. And so this happens all the time. And
that's even assuming that they let you know. That, who knows?
Yeah, InfoSec usually doesn't know about it. It's IT that says, like, we don't have time for that. Marketing goes, well, we could just go with external hosting. And IT is like, great, piss off. And, and then all of a sudden InfoSec gets the phone call. And this was another one. I had a guy at a very major online marketing firm that kind of does this for a living, called me up around midnight one night asking if we could get him some data on this because marketing come running and screaming. They had a big campaign that was collecting PII. And it had been breached, and their PII was breached. And he's like, we can't even figure out, like, they don't even know where this is hosted. They just told the creative agency, like, run with it. And the creative agency's not responding. So we don't know where to go. We don't know how to log in, get logs, anything. And yet now they've got stuff being disclosed. So that's the number 2. The number 3 one, and I expect this will eventually outpace marketing. I think we just don't know how often the number 3 is happening yet, but it's the new dev app in the cloud. It's the new test system that somehow gets plugged into prod. And we see these all the time. They're hard to pick up with our traditional ways we try to do recon on ourselves because they're not in our existing ASNs or IP address spaces, and they're often not tied to our existing domain names. They might be living on an IP address for now. And so the interesting thing is last year when we did this, we ran some queries and we found examples of 65,000 test applications. They were tested by, we found DNS entries in the cloud that were like, test and staging dot whatever, that had associated code in GitHub that had hard-coded passwords and config files, or were running default passwords and configurations. So you could just correlate from the GitHub to the test thing, and then you had the creds. So we know this is happening all the time, but it becomes kind of tricky for organizations to find. And so this became a problem for one organization that because the news lately, I really want to name, but we can't. It became such a problem for the CISO that they started deploying this root agent on all the boxes in the enterprise that would look for AWS keys and other cloud developer keys and API keys and collect them. And they would pull them back to a central repository, then go log into all those cloud properties, crawl or grab the code, pull it back to a central repository for analysts to then go look at and try to decide if it was a risk to the business or not. Well, they already had an overloaded InfoSec team, and now the CISO created this massive pile of every test piece of code and web page that was out there for the InfoSec team to look at and go, is this allowed or not? And do we need to go pen test it? And so obviously that mission was not successful, but that shows you the level of desperation for trying to figure out how to track this problem. Number 10 is outside of the purview of the business, is that IT starts playing with, they get into the wonderful DevOps world, and IT starts playing with auto replication and backups into the cloud without telling anyone. And we share this from personal experience. We might have discovered ourselves doing this late last year, so we know how common the pain is. We eat our own dog food using our systems, and so the way this kind of works out is somebody goes, oh hey, I want to set up this auto replication, and they play with all this. They start spooling up duplicates of everything in the cloud. They start to replicate data, but all the app servers are default passwords, and all the configs are default because no one's gone through and done any hardening. They didn't replicate a hardened system. They're just playing around with it to see if it works. But then they start testing data replication, and essentially now you have a backdoor. You have a backdoor into your production systems, and it only takes, from what we've seen, about 48 to 72 hours before some, general SQL injection bot or something that attacks an app server with default passwords and configs comes along and finds that thing. They know all the AWS IP pooling space, so they've got bots optimized and tuned to monitor and look for these sort of deployments. So, the last one. This was an interesting one for us because it became a major use case for our customers that they were operating in the EU. They're starting to get these 6-figure fines that are adding up into 7 figures. And it's particularly challenging for organizations that have subsidiaries. It's very common for US orgs to have independent subsidiaries that they own within each individual country in the EU. And then it gets even worse if it's a franchise model. And a lot of the EU countries, because of the privacy laws, have all sorts of reasons that they can't let you centralize the data. They say they can't share the data. They can be really difficult to do this. So you have to use public, open source, WHOIS, passive DNS data to kind of build this central database. Things go up and down all the time. How do you find all these assets? And then you need a way to monitor them at a DOM level for change as well. So you can find out when people change, how cookies sort of things go on. So conclusion from this, it's pretty obvious that based upon these breach things, there's a common pattern. We don't have global asset visibility, and we don't have a way to monitor them. But it's not that hard to do if we have the right data sets. And the data sets for most of this can be simply done with passive DNS, WHOIS. Newly registered domains is another really good one to catch these. And newly registered domains, I screwed up that bullet point. Actually, what you want on this one is you want new host name resolutions on existing domains. And there's a couple tools and ways to capture that from inside your organization. But when people start going to new host names, so newly resolved host names on existing domains, that's a great way to find like staging 3 dot whatever is now in the Amazon cloud, and they're resolving to it externally. And if you want to know, there's some free software out there you can use to capture that. Grab me after this and I can point you in the direction of that. You need some global IPv4 scan data, like a Shodan kind of thing, so you can start pulling all that in. And then the hardest thing to get is the crawl DOM data. So you need to be able to actually analyze the DOM to pull a lot of this apart. Okay, time check, 24. I think we're fine on demo-wise. Good thing I had the extra espresso. All right. So external threats. These are things that we've detected that adversaries are using externally to target employees or customers. Predominantly, it's shifting towards employees. And there's some common patterns we're going to talk about in this. The reason we find these interesting is they're all basically forms of phishing, whaling, or we could call it data theft. Many of these are malware distribution attacks, but essentially the malware is really just, again, going back to, it's either stealing creds or looking for PII or PHI, which is the goal of all the phishing attacks. And what's been kind of fascinating to us is there's like a bumper crop of products that have spun up to address each of these things individually. There's like mobile-only vendors and social media-only vendors and targeted spear phishing, and people focusing on domain infringement. And if you assemble the right data sets, it's all the same problem. There's actually very little uniqueness to all these different attacks, and that's what we're going to try to break down today. So, I mean, how many of you know who the Gruck is? Guy, oh, okay, I figured more in the room would. Guy who wrote one of the first anti-forensics toolkits and got fired from At Stake and went on independently, and he's the Gruck on Twitter. It's a great Twitter feed for InfoSec. It's probably one of the best out there, especially for forensics and investigations. Really sharp dude on blue teaming stuff, and he just said, started this year, he said, phishing's back to #1 again. We've raised the technology barrier, and we made it harder to exploit Windows 10, and we've made 0 days more and more valuable to keep in reserve for nation state actors. And the one thing that never changes and you never burn or get old by using it is phishing. And he's like, once you know how to fish, you're in. And I'll let you.
Yeah, I mean, so obviously coming from a research background, we do a ton of hunting inside the product. We do a lot of stuff with customers, things like that. And really what we've seen is just consistently the attacks have gotten simpler. They've become more effective in some of these cases. Anti-phishing is not very sexy. Stopping 0 days, stopping, vulnerability exploitation and things like that is really kind of the sexy stuff. And yet it's a million times easier to actually phish somebody and ask them for their credentials. We've got things like two-factor auth that are coming into play. And it's starting to help in certain situations, but if somebody's going to actually input their password into a web page, what makes you think that they're not going to put a two-factor auth code in that same damn web page? So we have to kind of look at some of these and figure out what the best approach is on these. And the other thing is, honestly, these guys are building out real scalable applications. They're targeting multiple brands. They're doing it in a consistent and scalable manner. What we're seeing is the same analytics tools that we use as regular companies, they're using because they want to improve their effectiveness too. And they're kind of like, why should I build that myself when I could just go to any of these analytics places? And we find a lot of that is really, really interesting because we can start pivoting off of that. Some of the other stuff that is really interesting to us is they're using cloud stuff just the way that we would. They're standing stuff up very rapidly and shutting it off. They're not using as much compromised infrastructure as they were for the dedicated stuff. They might use it for some sort of redirection or initial landing page or stuff like that. But some of the more advanced guys are actually setting up dedicated infrastructure. They're setting up dedicated domains. They're setting up dedicated IP space. And there's actually some sophistication going on. And there's definitely some innovation that we're seeing on the simpler side of attacks. And to Arian's point, I mean, if you look at the attack surface these days, Windows 10, OS 10, all these different operating systems are making successful exploitation a much more difficult, effort. And a lot of times, if you have that system actually set up where you need to be, it's actually secured and hardened, they're not simple targets like they used to. I mean, gone are the days of being able to run into a place and pop 50 shells within 5 minutes. I mean, I love those days. I didn't love defending it, but it was pretty fun.
There's one thing I want to hit before we go into that. So, I mean, to be really clear, what's interesting is that we've actually seen the sophisticated adversaries have actually been adopting DevOps build tools and auto-replication at a faster rate than many large organizations have. So they're actually outpacing them at dynamically copying. We've seen adversaries that automatically completely clone perfect copies of websites in under 15-minute intervals. They've got active monitors running, they pull all the code in, they rebuild it, change the paths, pump it out, they move it around arrays of domains. They have large TDSs. We have separate presentations about their TDS networks and infrastructure if you want to learn more about that. We don't have time to go too in depth on that today, but regardless to say, they're taking advantage of the low cost of cloud and all the software that our business is embracing to lower the cost of deployment, replication, and performance, and they're leveraging it to set up very complex threat infrastructure. So I'm going to take a simple example today. So this is basically, I'm not sure what language this in, but this Perfil, it's Profile Google. This is a fish. This is a fish that automatically, this guy's fish all just automatically copy Google stuff. So whenever Google makes a change, he's automatically building it in and including it. And what's interesting about, so how did we catch this? I'm going to cheat a little here. I'm going to show you how you can catch this, but I want to show you something interesting here first to us. So the way we initially caught this was actually using page hashing, which I mentioned earlier. And so when we first saw this thing, we decomposed it, all the headers, all the components, everything in the DOM, we decomposed it into a min-hash tree. So it's basically a tree of checksums. And then we ran it against our global database of checksums. And this one, usually we don't get this clear of a hit. We use machine learning, and the algorithm we found that has been one of the most successful, we usually combine algorithms and machine learning for analysis, but in this case, DWKNN, which is distance weighted nearest neighbor, was actually a fairly simple machine learning algorithm. It's one of the most effective with min-hashing for anti-phishing, because we're comparing these checksum trees. And so with DWKNN, what we're doing is we're combing a whole database and say return the 9 nearest neighbors, return the 10 nearest neighbors, like what things have the closest matches. So it's not much different than a decade ago what Halvar Flake first published and introduced with comparing families of malware samples using checksum tree analysis. The same thing we're doing on the web. In this case, when we return the 9 nearest neighbors, we usually have a weight. It's like, well, are the first 4 bad, something like this. In this case, all 9 match known active phishing campaigns. Even though the web pages visually at all 9 of those look entirely differently, there's enough shared componentry and checksums that it's like, okay, this one's obviously a phish. But actually, let's dig in and look at this. So, there's some cool stuff in this one. This is going to be so annoying to drive in multi-window. All right, so now we'll look at the data set here. And so the first thing we can see is that I need to window resize. There we go. All right. So what does the data tell us? So the first thing we're looking at here is passive DNS data. So we can see this guy did a few tests here to see if he would get any hits on this. Probably had some success. So this campaign is really new. It hasn't run for very long. So this is a brand new fish we've caught, is what passive DNS data is telling us. But let's move on and let's look at who is. So who is records we've got. I usually like to use email, name, and phone number because those are about the only things with uniqueness. So let's look at what we have here. Okay, we see a pattern really quick here. We don't know if this guy's targeted. Doesn't look like it to me. This looks like just a generic scammer. And whoever this scammer is, he clearly likes profile type attacks. He makes these fake update your profile things. That's his phishing scam. What we can also see from here is, let's pop over from who is. So if we actually query his name, we can see he uses some different email addresses too. So we can start pivoting off the different email addresses. And we can come over here. Oh yeah, he's got some other accounts there. But now I want to do something else. I want to come over here and now I want to look at the web components and compare. So if I did have some doubts or confusion, is this real or legitimate or not? This is a very rudimentary but effective example. I'm fairly sure none of Google's properties are running ASP.NET deprecated version of 4 on iOS 7.5. I think we can confidently say that's not Google's technology stack. So with some very basic data sets like this combined, you can very quickly make a lot of decisions and just move on. Like, we don't have to pass go now. We know there's all sorts of indications of badness. It's a generic scammer. And so now we can just go back and let's find everything. I think that's another example we probably won't get to today. Yeah. So now we can just go back and take all the different things we've mapped out on all those different email addresses and just block it all at once. No reason not to. And we can even go drill into all the passive DNS IP addresses and see what else is associated with them if we have time, which we don't today. So 35, 45, let's go back to, PowerPointing you to death. We do have more examples. All right. So so-called whaling, domain infringement. Whaling attacks, and some people are referring to them as spear phishing, but the pattern we notice with whaling attacks is, again, it goes back to this, what I call impersonation. So in the first phishing attack, most phishing attacks use some form or usually multiple forms of impersonation. So do whaling attacks. And almost all of them that we've seen use some form of domain infringement. And it's usually pretty easy to detect domain infringement. And these are easy to pick up if you add in the data set of newly observed domains. If you have a mature organization, by default, newly observed domains that infringe or collide on your namespace, your spidey senses should automatically be tingling. Mature businesses at this point don't usually go out and start registering a bunch of new domains at once, but adversaries do. But we can also correlate a few other data sets, which I'm going to show you here, to answer some other questions. Am I targeted? Like, is this just a shotgun spammer? Like, I'm going to block all that profile dude stuff, but I'm not too worried, right? He's not really targeting me. There's probably more my customers than my employees. My employees aren't going to go to Facebook profile update and put in their company password. I'll block it all, but it's like, I'm not going to waste any time on it. Here I want to know, okay, do I need to worry about this? How sophisticated is this adversary? Do I need to flag them? Do I need to put monitors on these data sets to see when they set something new up? And how many ways are they going to try to come for me? So actually, on this one, we actually had a CFO. I can't give you the live example for some obvious reasons, but I'm going to give you an almost identical example. And this one that I'm going to show you is a live, active. He's both a targeted phisher and a whaler. He goes after executives. And so this same exact pattern, we had a CFO get whaled. It was a payroll scam. Hey, you're not going to make payroll. You know, the corporate account is frozen. We need you to come unlock it. You're going to have to transfer in this into this account to show you have funds. We need you to log in here, blah, 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 blah. They whaled the CFO. They figured out that they got owned. And so they called us in, and literally while we were there on site investigating this, they got whaled again. They targeted another exec. And so let's look at this. They were trying to correlate all this by hand, and it's kind of crazy. So the funny thing is, this guy's sites aren't actually that sophisticated, but he is auto-replicating code off these different banks. So this particular domain that we started with, this particular whale attack came from this targeted exec from this PNC Online Banking Mobile Personal mouthful. All right, let's find, here it is. Drag this over. All right. So once again, there's some things we can tell immediately. This guy's been at it a long time. So is this a new attack? So this started earlier this year. So depending on what you consider new, it is newer, but it's not a brand new attack. Didn't just start this weekend. This guy's been at it a while, but let's look at some more stuff to see if we can figure out. Oh, in this case, and I really like this guy because he's still active, but who knows if that's his name. But this guy is really consistent about using the same name and email address on a lot of different campaigns. Eventually he's going to figure out and anonymize this who is, but there's already enough internet space junk out there that can be used to track him that it's like a little bit too late now. If who is goes away and you know where to go. So let's start going through this. So the first thing we do is if we pivot off who records on his email address. We see there's 153 results, and we can look through, and all we're going to find here is just the same email address, different things. Now, when we first look at this doesn't look targeted, right? This looks like a generic phisher, scammer. I mean, we got everything from password cracking to Adele album to live sports to some sort of iCloudCom.com. This guy really likes the -com.com. So we're going to come in and we're going to pivot off his name. And we see off his name, we actually find a slightly different set of data than if we pivot off his email. And we see some weird shit.net. So I don't know can you in the back read any of these domains? It's too, okay. Literally the first domain registered to his name is weirdshit.net. That's hence the not very funny joke. I like to go with obvious. So we found some stuff there that makes us think this guy isn't really targeted. He's been running this for a while, but I don't have to worry too much, right? I'm not going to sweat it. But there's something else we saw when we came in here, and that's we identified that this guy uses Google Analytics. Now, there's two ways that this can go, and we got 10 minutes left, so I got to speed up. Less sophisticated adversaries that are auto-cloning and replicating websites will clone all the trackers. The New Relic ID, the Google Analytics ID, the Yahoo Ads ID, they will clone it all off the legitimate site. So when you find a copycat phishing site that's got the legitimate trackers, but they're on a like .ru host in Russia, you know, okay, Bank of America is probably not operating a lot of campaigns in Russia. That's a fish. And two, this person isn't real bright or sophisticated because they just copied everything that allows us to detect it really quickly. In this case, though, this guy drops all the trackers and he uses his own. So he pulls in all the web components, but he has his own tracking ID. And so let's go in and look at that and see if we can learn a little more here. I cannot mouse this way. Oop, jumped ahead. So let's look at his Google Analytics account. So this specific Google Analytics account has 23 records. And what do we notice about the 23 records? Every one of them is targeting PNC Bank. So now my spidey senses just went up a notch again. Okay, this guy has a lot of shit out there, but this is actually targeting PNC. It's clearly going after him. So now let's look at the individual IDs. So what I started finding is if I go through, so I'm looking at Google Analytics ID 51, and then here's 15. I just started brute force fuzzing through his Google Analytics IDs. He actually separates out domains by structural patterns and assigns them to individual Google tracking account IDs to track them separately for some reason. I don't know why, but now this is implying a level of sophistication and targeting. I got to worry about this guy. And he's running these at different time frames. If you go back and look at passive DNS and heat map them, you'll see him go live, shut things down. This is an adversary we need to keep an eye on and get ahead of. And we can continue to keep pivoting off of this. Now, the other thing I did that was interesting is so I went in to one of these and I started going through the individual domains and I found new Google accounts on some of them. So he has more than one Google Analytics account. So I came in here off the ones to see you can find on this PNC-online-mobile-banking-personal. He's got two different accounts and two different tracking IDs. So I drop into the other Google Analytics account and guess what? He's got another set of domains targeting PNC Bank. So the rabbit hole just goes deeper and deeper, but using this, you can go way beyond who is. And you can do the same thing with SSL facets as well. And I do not have an example of those. So we are going to try to wrap this up in 7 minutes, which means... Come on. All right. What do we know about social media? Attackers are rapidly embracing it. It's actually outpacing mobile. And social media, again, the attacks are phishing. Why do we think this is? Hence the graphic. Social media has the largest concentration of users. It's a distribution choke point. And it's also a distribution choke point that provides the adversaries with sentiment analysis. I love Wells Fargo. Starbucks sucks. The adversary already has a context now to approach you and engage you. Plus, they have all sorts of information. They have your target. They have Starbucks logos, keywords, all this information about them and you. So now they can combine that very effectively in an awesome stalkerish way. So you get this immediate exposure. They can also use hashtags. The campaigns are faster than regular fish. Regular fish campaigns we see last an average of about 32 hours. We see about 5 to 8 hours on social media. And the reason why is because so many social media sites are weakly authenticated. So they can just automate bulk creating and dumping new accounts very rapidly. In fact, I think some of the social media that don't know how to monetize as well actually like that extra user volume in their traffic, but that's speculation. The two biggest things we see are fake customer service. Hey, I'm sorry you're mad at us. Did you know we have a 24-hour service guarantee? I'd like to correct your problem. But first, I'm going to need to collect a little information from you. Could you log into your account so we can get started? Click here. Right? And some of it's, they've got this automated down to what feels like bot level. And the second one is, hey, we're glad you like us. You're the thousandth customer to say, I love Starbucks. You know, what we'd like you to do is you click here and download your free gift card. So these two things, again, are phishing. The pattern, though, is both attacks will use links that lead back to the same threat infrastructure they use in web phishing, and actually the same links that they'll use in mobile phishing when they siphon off data. And I'll give you a quick example of this. This was from customer service here, and then I'm going to blow through and turn it over to you, James, so we have time to get through this. This is the last one of these. And mouse, let's get it up here. So the links to this one basically led back to log into your account, so we need to get some data to help you out with the fake customer support. So again, this is, and this is no different than what we see with traditional web phishing or with the targeted whaling, all this. I've got this account. It's pretty straightforward. I come in. I can see it's been running a while. I look through. This guy, once again, looks like a pretty, this guy has almost 1,500 domains. So he's a pretty active broad-scale shotgun scammer. Doesn't seem too targeted, yet we have these targeted social media accounts. We come in, and now I'm pivoting off his name instead of email address. He has 3,000 more records. And so from this, now you can parse through and you can start finding he has a bunch of different email addresses. Now we have to come pivot off all the different email addresses. Here, this email alone has another 2,400 records. So we start doing this combined pivoting, but using the data sets again, we found this one has 304 results. So he has all these randomized generated domains. James thinks they were for old scams. We can discount those. I was trying to figure out if he's a TDS. Phone number. Now here's where it gets kind of interesting. Again, the Google Analytics changes the story. This guy not only targets PNC Bank, but he targets Capital One and Intuit and a couple other things. But it's predominantly banks. There's Chase in there. There's 25 results. I drop through the records, and now I go, oh, yeah, this guy does run targeted campaigns. When I say guy, this is probably a team of people. It's probably some cyber criminals that are monetizing. So long and short, as you go through the different tracking IDs, you'll see they'll break up the groups of domains and run individual tracking campaigns targeting specific institutions. So it's probably a group of threat actors putting this together. And the only funny thing is, so I went through the web components to see if we could sort out, and I actually found this adversaries, their stacks, their technology stacks they use are almost identical to Capital One, because Capital One appears to use everything in the kitchen sink on their web stacks. The only difference is the adversary keeps their WordPress patched and up to date. When I went to the actual Capital One infrastructure, they were actually running all these legacy deprecated versions of WordPress, which was pretty funny to me. Probably not to them. Okay, James. I am going to, I think from the nods and the people leaving the room, I think everybody gets the idea that these are all the same. I was going to say on mobile here, you're really targeted or you're not. That's why all these mobile vendors are evaporating. And to give you an example, like Halo, for some reason, they're one of the most targeted brands on the internet. There's almost 4,000 rogue mobile applications out there, you know, where some people have none. It's like one of these very polarizing, you're either targeted or you aren't. Wrap it up, James.
Yeah, so one of the other huge things that we run into a ton in our data set, obviously we do a lot of anti-ad fraud and targeted attacks inside the malvertising space. So we see a ton of that data. Most of it's, at this point, like I said before, they're trending towards low-tech stuff. So they're doing scams, they're doing, fake software, things like that. We're seeing a lot less of the traditional exploit kits, things like that in our data. And really one of the things that's interesting about the ad ecosystem is how complex it is. If anyone has any questions, by all means, come back to us. I can talk to you around the booth, probably for hours on the ad ecosystem, but yeah, I know. But one of the things on the malvertising side, we see TDS is used almost every single time. There's all sorts of traffic distribution, there's traffers, there's an entire underground ecosystem related to this stuff. You see browser lockers that are very common. This is just an example of one of the old NSA browser lockers. Really, really awesome English that's in there. I highly recommend checking out some of those screenshots at some point. But one of the other interesting things is the third-party web components. We've seen a ton of people targeting that stuff just consistently. They're popping web servers. They're trying to pull in user credentials and things like that. And one of the biggest issues that we're seeing, back to the phishing, is so many people reuse their passwords. Password reuse is one of the biggest issues that us as security practitioners are facing, because all it takes is one user to give their password up. It takes a forum dump, where there's, tons of passwords in there. They can brute force that stuff, no problem. And honestly, all it takes is one weak website. If they're storing stuff unencrypted, today we had the Yahoo breach, where there was a ton, like 500 million accounts. And how many of those people do you think actually reuse their password? I'm willing to guess that a large percentage actually do.
I want to add something here on that slide. Yeah. So to be really clear here, we actually started seeing the first indications of targeting third-party components by multiple groups were CDNs. We saw threat actors specifically going after CDNs because then they get like a 1 to 1,000 multiplier of content they can get after, and then they would just change a little bit of content to start sourcing in their attacks. And now we've started seeing them targeting third-party widgets, could be marketing like Eloqua, that sort of thing. But the main thing is most of these things are outside the scope of the red team, especially these third-party vendors like Eloqua. So none of that stuff's getting tested, but it's getting sourced in and built into your DOM. It's part of your application, and it manifests itself at runtime, but it's usually out of the scope of everything the red team's doing.
Yeah.
And your phone scanners won't ever see this.
And that's an important thing. I mean, oftentimes, these components aren't ever in scope as far as assessments go. I don't know time-wise whether we're...
We got like 2 minutes.
Got 2 minutes?
Yeah,
we'll roll through this real quick. So this is actually a really interesting attack that we've seen recently. We're going to be putting a blog post out on this probably Monday or Tuesday, sometime around then. But basically what people have been doing is they've been targeting online shopping carts. I'm sure if anyone here has worked with e-commerce sites, OpenCart and things like that, you guys probably are just rolling your eyes. There's so many vulnerabilities. It's like the WordPress of the shopping cart world. But really what's interesting to us is some of the attackers have actually gone to different lengths, and they've been starting to attack the client that's connecting rather than the server itself. So what they're doing is client injections into the web pages, grabbing the forms, and then basically posting that and exfiltrating the credit card data on that stuff. We've seen a ton of these websites that have been there, and I'm really sorry that the text is tiny. Anyone that wants to talk to me afterwards, I can share screenshots and things like that. But basically what they're doing is they're injecting this piece of JavaScript that looks like legitimate JavaScript, and basically what they're doing is, so on this one, what they're doing is checking for form data. They're checking to see what sort of software is running. They're pulling the credit card fields as soon as the data is submitted, and then they're pulling that data over, a couple different ways. But we've seen some really interesting websites that have been popped. There's a ton of, we saw one that was a bank, their internal store. It got popped through this, and kind of interesting. So anyone that's interested in this, feel free. Sorry I don't have enough time to really go through this. But feel free to hit me up afterwards, and we can share more information.
Yeah, the bottom line is that same attack again. They're essentially rewriting the template of the JavaScript structure to insert keyloggers and grab data. But they have to send it somewhere. So if we go back to our passive DNS, who is, what new host names, what new domain names am I connecting to and sending data to? If I'm managing my attack surface and I maintain it that way, and all of a sudden I see some new third parties that I'm sending data to, and I can go start investigating them. And by combining these data sets, it shouldn't take you long to automate looking at them and go, oh, it's Fred and .ru again, or this is going to these things with these Google Analytics not related to us, et cetera, et cetera. With only 3 or 4 pivot points, you should immediately go like, oh, this is way bad. I need to shut this down immediately. Thank you all for coming. We really appreciate you.